So picture this. You're looking up at the night sky on a perfectly clear, incredibly dark night. Every single star you can actually see with your naked eye, that's just our tiny local neighborhood right here within the Milky Way. And our galaxy is just one among hundreds of billions of galaxies out there. It's a scale that honestly almost completely defies human comprehension. But for just a minute, I want you to imagine something even bigger than that.
Okay, let's dive into this. Welcome to this explainer on what has to be one of the absolute most mind-bending concepts in all of cosmology. Today, we're exploring the mystery of the multiverse. We'll be looking at exactly where this incredible idea comes from, what the leading scientific models are actually suggesting, and asking if we could ever really find proof that we aren't alone in the grand cosmic scheme of things. Section 1. Beyond our observable universe.
Now, before we can even begin to talk about other universes, we kind of have to completely shift our perspective. We need to zoom out and ground ourselves in what we can actually see. The observable universe is strictly limited by the speed of light. Because the universe has a specific, finite age, light from the most distant objects has only had a certain amount of time to travel across the cosmos to our telescopes. And what this means is that our observable universe isn't necessarily the entire universe. There could be vast, literal infinities of space so far away that their light simply hasn't had enough time to reach us yet. So when scientists talk about the universe, they're already dealing with a reality that's likely much, much larger than what we can directly observe.
And just think about what's packed inside that observable bubble. We're talking about hundreds of billions of galaxies. And inside those galaxies, uncountable stars, orbiting planets, massive black holes, and undiscovered worlds we haven't even begun to map. The sheer scale is absolutely awe-inspiring. But could there be something beyond our universe entirely? Well, that is exactly where the concept of the multiverse steps in.
Now, I want to be super clear right out of the gate before we go any further. The multiverse is not one single unified scientific theory, and scientists have absolutely not confirmed that other universes exist. Ideas about the multiverse actually come from attempts to solve some incredibly complex problems in modern physics, quantum mechanics, and the birth of our own universe. It's a fascinating, mathematically viable possibility, for sure, but it's not yet an established fact. We are quite literally exploring the absolute cutting edge of theoretical physics today.
Section 2. The bubble universe theory.
According to some major cosmological models, right after the Big Bang, the universe underwent an extremely rapid, violent expansion. Now, the theory of eternal inflation suggests this process didn't just happen once and then stop everywhere all at once. Instead, inflation might continue forever in some regions while stopping in others. The places where this extreme expansion stops, they cool down and form separate, isolated bubble universes. So our entire universe could just be one of these bubbles. And somewhere way, way out there, beyond our cosmic horizon, there could be countless other bubbles expanding in an endless cosmic landscape.
So, imagine those gigantic cosmic bubbles expanding through this unimaginable space. What happens if they get a little too close? What if two of these universe-sized bubbles actually collided? I know it sounds like a massive comic book crossover event, but cosmological models have genuinely explored this possibility. If a massive collision happened in the distant past, what would that actually mean for us today?
Well, if another universe physically bumped into ours billions of years ago, the impact might have left a sort of cosmic bruise. Scientists hypothesize that a collision like that would leave unusual circular patterns in the cosmic microwave background. That's essentially the glowing radiation echo left over from the Big Bang itself. And researchers have actively scoured this radiation looking for these exact unusual signals. But keeping ourselves totally tethered to the data here, so far there is no confirmed evidence of any such collision.
Section 3. The quantum multiverse. Let's completely shift gears here. We're zooming all the way in from the massive cosmos down to the bizarre, tiny subatomic level. And this brilliantly illustrates just how weird quantum physics can really get. At the subatomic level, everyday logic completely breaks down. The many worlds interpretation is a concept proposing that when a quantum event occurs, reality doesn't just pick one outcome. Instead, every possible outcome actually happens, just in different branching paths of reality.
Let's walk through exactly how this works. Step 1, a quantum event occurs. Let's say a particle spins left or it spins right. In our standard everyday view, we observe it spin left, and the right option just kind of disappears. But in step 2 of this model, instead of one outcome being chosen, every possible outcome is realized. And finally, step 3, reality itself actually splits. The timeline diverges into an enormous collection of branching possibilities. Instead of one single linear history, you get an endlessly branching tree of parallel realities. Which naturally leads us to the most famous and frankly deeply personal question about the multiverse. If reality is constantly branching based on different outcomes, could there be another version of you out there? Somewhere out there, did a totally different Earth develop? Did history take a completely different path? Did you make a different career choice or even just wear a different shirt today?
Look, it sounds exactly like a sci-fi movie, doesn't it? But we have to look at the facts. Science has absolutely not discovered another Earth, another version of you, or, a version of you who actually went to the gym this morning. We have zero observational proof. Yet, the mathematics behind these quantum theories are incredibly robust, and they mathematically allow for hypothetical scenarios that are just deeply, deeply difficult for our human brains to imagine.
Section 4. Different laws of physics. We could even have entirely hostile universes. Think about a universe where the force of gravity is just a tiny bit stronger. It might collapse in on itself immediately after forming. Or what if electromagnetism was weaker? Stars might never ignite at all. Our universe, however, is essentially a Goldilocks zone of physics. The numbers are tuned perfectly, just right to allow for galaxies, stable stars, planets, and ultimately, us. Why is our universe so perfectly suited for life, while others might just be dark, empty voids? This incredible, perfect balance brings us to something called the anthropic principle. This is the philosophical idea that our universe has perfectly balanced conditions because, well, if it didn't, we literally wouldn't be here to observe it in the first place. Some multiverse models use this principle to explain our existence. If there are trillions of universes out there with totally random laws of physics, most of them are going to be dead and empty. But by pure chance, a few will get the winning lottery ticket of physics, allowing life to form. We just happen to live in one of the lucky ones because, well, it's the only type of universe we could possibly exist in to even ask the question. Section 5. Searching for cosmic proof. So we have bubble universes, branching quantum realities, and completely varying laws of physics. But how do we bring this back to hard observable science? Well, we face some incredibly hard limits. If another universe exists completely outside our observable region, detecting it is a monumental, maybe impossible task. The limitation isn't just that we haven't built a big enough telescope yet. The real barriers are the fundamental structure of space-time itself and the finite speed of light. We are completely trapped within our own cosmic horizon, physically barred from seeing past a certain point. Because direct observation is literally impossible under our current understanding of physics, scientists have to get creative and hunt for indirect evidence. Like we discussed earlier with the bubble collisions, they look for anomalies in cosmic radiation, or maybe strange gravitational pulls coming from beyond our horizon. But to date, despite some of the most brilliant minds on Earth dedicating their entire lives to this, nothing has given us definitive proof of another universe. And that's exactly what makes this whole topic so astonishing. The multiverse sits perfectly on the razor's edge. On one side is what science can rigorously investigate, and on the other is what may remain forever beyond human observation. Whether there is just one universe or trillions upon trillions of them spinning out in the dark, we still don't fully understand why our universe exists at all, or why it works the very specific way it does. Which leaves us with this final, beautiful unknown. Maybe one day, a massive breakthrough in physics will pull back the curtain and finally show us the multiverse. Or maybe the answer will stay hidden forever. Because perhaps the greatest mystery isn't what lies at the edge of our universe, but whether there's an edge at all. Thanks for joining me on this explainer. Keep asking questions, keep looking up, and remember, the universe may be vastly stranger than we can ever imagine.